So in previous video I derived an expression for relativistic kinetic energy, and there we encountered this expression m naught c squared, which we call as rest mass energy. So the title of this video is that can mass be converted into energy, or what does this E is equal to mc squared mean? So let us consider that we have an proton which is at rest, that is there is no kinetic energy, and also it is not in any kind of potential field. So therefore the total energy will be rest mass energy, which is given by m naught c squared. So this is the total energy or the rest mass energy of this proton, and the mass of proton is 938 MeV by c squared. So MeV by c squared is the unit of mass which is widely used in nuclear physics or atomic physics. So the energy, rest mass energy of proton is 938 MeV. Similarly, the rest mass of an electron is 511 keV by c squared, and therefore in the units of MeV we can write 0.511 MeV by c squared. So the rest mass energy of an electron will be 0.511 MeV. Now consider that we have one proton and one electron, and these two particles are non-interacting with each other. So the total rest mass will be rest mass of proton plus rest mass of electron, which is 938.511 MeV by c squared, and therefore the total rest mass energy of this configuration will be 938.511 MeV. But now if these two particles are brought together such that they form a hydrogen atom, so the energy is released in this process. So if the hydrogen atom is formed in the ground state, so the energy released will be plus 13.6 eV, and therefore the rest mass energy of this configuration will be the 938.511 MeV minus 13.6 eV. So now you see in this particular example the rest mass has been decreased and the energy has been released. So it means that the rest mass depends on internal arrangement. If we have the one arrangement of particles, so they can have a specific amount of rest mass or rest mass energy, and another configuration they will have another rest mass energy. So basically rest mass depends on internal arrangement. So this is for composite particles only. And now take another example. If we have two protons and two neutrons, and these are non-interacting, so of course the rest mass energy will be the total rest mass multiplied by c squared. So we have two protons, so 2mp plus 2mn multiplied by c squared. So now this is the total rest mass energy of four non-interacting nucleons. But if these two protons and two neutrons are combined together to form an alpha particle, so the rest mass energy will decrease, and this decrease is basically minus 28 MeV. It means that when this combination is formed, so 28 MeV energy is released. Okay, so now rest mass decreases and energy releases. So that is the relation between energy and mass. So basically this is the same process which happens in nuclear fission. So this is the same principle through which we get energy. So we have a larger nuclei, and that is we have one configuration, and we do some process by in which this heavy nuclei, this one configuration is changed into another configuration, and new configuration will release energy. So this process of shifting one configuration into another configuration will releases energy. So that is the idea. For example, if uranium 234 is used as a fissile material, it is used as a fuel. So if we have 92 protons before the reaction, so we will also have 92 protons after the reaction. So if particles are not being destroyed, then why are we getting energy? If mass is not converting into energy, then how we are getting energy? So we are getting energy because the arrangement has been changed and the new arrangement is giving us energy. So that is the idea behind nuclear fission, or how the energy can be converted into mass. Similarly, if you look at a spring in its natural state, so it has some rest mass, so therefore it has some rest mass energy. But if you apply a force and compress this spring, so now you see work is done on this spring. So work done increases the internal energy, and therefore if the rest mass energy is increased, so it means the rest mass has been increased. So yes, we can decrease it or we can increase it, so it is related with the energy. And similarly, the hot objects we know have more energy, therefore hot objects have more rest mass. So the summary of all this is that particles are not destroyed, particles are not converting into other particles, but their different arrangements give us energy. So that is the idea. So that is the meaning of E is equal to mc squared. But now there is another question. Can we have some process in which the mass is destroyed into energy? Mass is completely converted into energy. So yes, there are some processes in which the masses are converted into energy and vice versa. So here is a famous process. This is known as the electron positron annihilation. So we have one electron and a positron, so they combine to give the two gamma photons. So electron and positrons are completely destroyed, but you see these are the massive particles, they have masses. But now here the mass is converted into energy according to E is equal to mc squared. So yes, mass can be converted into energy, mass can be destroyed into energy. And also there is a reverse process which is known as pair production. So two gamma photons can be converted into an electron and positron pair. So here you see energy is converted into mass. But you should remember that there are few processes, and these processes or the reactions are basically limited by conservation laws. For example, this pair production or the pair annihilation happens in daily life. But if you have one electron, so no matter how much energy you give it, it will never convert into energy. It is because the conversion of single electron into photon is limited by conservation laws. So we have some conservation laws which prohibit various nuclear reactions. So the summary of entire thing is that the rest mass decreases, so the energy will increase. So if rest mass is decreasing in a particular reaction, so the energy is increasing. For example, if delta m is the mass decreased in a reaction, so delta m into c squared will be energy released in that particular reaction. And also mass can be converted into energy by a few nuclear processes which are governed by conservation laws. So that is all for this video.